Hello and welcome to this lesson. In today's lesson, we're continuing our series in looking at different problem-solving strategies that students can use when solving a math problem. Typically, students struggle the most with problem solving in math. As soon as they see a word problem, they tend to clam up and get scared of it, but we don't want this to be the case. That's one of the most fun parts of math, is the problem solving. That's the really important part of math. So we teach students how to look at problems and read through problems, but we also need to teach them different strategies and how to solve problems. When they look at a problem, they can have a plan of attack with how to solve it. So today's strategy we're going to be looking at is a systematic approach. And what this means is just a way of providing structure to a problem. It's really just coming up with a plan of attack, being organized and not doing it in a random way. These are really good for problems where you can't check your solution. And I'll show you what I mean with an example. So here's our first example. How many triangles are in this shape? Oftentimes students will come up with an answer for this one, and I'll ask them, are you sure that's the right answer? Or how did you come up with that answer? Because they'll just kind of count and come up with an answer. But that's not a great way to look at this problem. First of all, we can't see their thinking and their learning through it. And second of all, how do we know that's the right answer? Did they miss any? Did they double count any? So we want to have a way of organizing problems so when someone looks at a solution, we can know their thinking, and so that we can be pretty confident in our own answer. So as we look at this problem, we look at this shape and how many triangles are in this shape. We could just try to count it, but we're going to try to break this problem down systematically, organize it in a nice way. So I like to organize this problem into the size of the triangles, because if we look at this, we can see really that there's three different size triangles in here. We have our tiny triangles that are just made up of one triangle, but we also have larger triangles that are made up of 4 different triangles. And then on top of that, we also have these big triangles, that is a terrible picture, that are made up of 9 triangles. So that's all the possible sizes of triangles. There can't be any smaller, there can't be any larger. So if we can count these 3 types properly, then we can be pretty confident in our answer. Let's start with the tiny triangles. Those are pretty easy to count. We can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can count 12 of those tiny triangles, and we're pretty confident just from looking at it that that is all of them. So pretty good, the small ones. Let's go next to our largest triangles. We can see that there is really 2 of the large triangles, and we're pretty confident there's no more and no less of those. And finally, we have our middle-sized triangles, and these ones are the trickiest. These are the ones that are made up of 4. So if we look at our big triangle, let me do that green again. Let's just look at one of our big triangles and start there. And then since the 2 triangles are the same, whatever we find in this one, we can just double, because we know it's going to be the same in both. So we have one here at the top, all right, that tip. But if we look at our other 2 corners of our triangle, we can also see the same thing. So at each corner of our triangle, we can make one of those mid-sized, one that contains 4 little triangles. And because a triangle has 3 corners, we can be pretty confident that there is only 3 of them. And that means in the second bottom triangle as well, this one back here, it would be the same thing. We would also have 3, one coming from each corner of our triangle, which would give us 6 total. Which now we can just add these up, 12 plus 6 plus 2, and we can get 20 total triangles. And we can be fairly confident in our answer because we broke it down nicely into a systematic way. And now we're not just guessing. If someone asks us how we got it, we can kind of show them our thinking as well. So that is our first problem, the systematic approach. We've organized it nicely. Let's look at a second example. This one says, how many numbers between 1 and 100 contain the digit 5? So we could look at this problem, and a lot of students will probably start it. They would just start by counting. Some students might even look at it and be like, I don't even know how to start it, and I'm going to give up on it. But that's why we want them to come up, okay, let's think about it and come up with a nice organized way. There's probably a few different ways you could organize this, but I'm going to organize it by digit. We know that numbers between 1 and 100, except for 100, but it doesn't have a 5 in it, have 2 digits. We have a tens digit and a ones digit. So we know if our number is going to have a 5 in it, it's either going to be in our tens or in our ones. So let's start off with our tens. If there's a 5 in our tens digit, that means it's a number that's in the 50s. So we could have 50, 51, 52, 53, 54, all the way up to 59, right? Which gives us 10 total numbers. And we can be sure that those are all the ones with a 5 in the tens digit, because we know those are all our numbers that are in the 50s. Same with our ones. If there's a 5 in the ones digit, it's going to be 5, 15, 25, 35, all the way up to 95. And by organizing it this way, we can be sure that we haven't missed any, because tens and ones are the only digits, so it's either in one of those. So this gives 20 total numbers, but, and here's again why I like this solution. If we look at this really closely, we notice that there is a number that is counted twice, 55. It has a 5 in both the tens and ones, so it's included in both lists. But it's only one number, so we can't include it twice. So by organizing it this way, we're also not double counting a number. So I'm not going to include the 55 in our ones digit. So that would give, then, not double counting that, 19 total numbers between 1 and 100 that contain the digit 5. We have our 10 numbers over here and our 9 numbers over here for 19 total. And again, by organizing it nicely, we can be pretty confident that we haven't missed any, and we know we didn't double count any because we caught that. So here's our systematic approach. Just a couple examples of how to nicely organize a solution. There is attached to the link of this video a link to a worksheet that has more problems. The best way to learn math is just practice. So lots of problems that you can just practice the systematic approach, and there's also solutions there as well. And as always, for more great math content, you can check out Math Fun 101 on Instagram and Facebook.